So before we start talking in some detail about some of the issues in operations management, it would be very useful for us to understand that there are some configurations, standard configurations that operating firms fall into. So today we will start with a continuous flow system, which is one variety of operational configuration that we see. Let's take an example of an automobile manufacturing and let us try to understand what really happens there. So typically it starts with the chassis, as we all know. In fact, typically an automobile assembly may have about hundreds of stations. It starts with the chassis, then on the top of it several things are assembled, and then you start adding several parts. So let me call it as parts assembly, and there are feeder parts which are available. There may be several stations. Then the doors, let us say, are added to the car. Then it goes through a painting booth where the color of the car is being painted. Then there are several stations, several checks are done, and finally you have the final quality check and the car rolls out. Right? This is a typical process. There could be, from here to here, there could be easily about 100 to 200 stations. It all depends on how elaborately this is organized. We will take one more example, which is a fast food joint where we go and let's say have our breakfast or a quick lunch. So again, what you find here is customers arrive, maybe there is a cash counter where we order whatever dish we want, cash payment is made, then we move on to a delivery counter if we are going to sit down and then eat in the fast food joint itself, and we pick up the dishes, and then there is this dining area where we sit and have our snacks or whatever, and then we dispose, and then we depart from the service system. So here is one manufacturing example and one service example, and if we look at it, there are a few things which we will notice. The first thing that we will notice is such systems typically will have low variety, let me call it, and high volume. This is very characteristic of such systems, which really means that the flow will be very, very streamlined because of low variety and high volume. And if flow has to be streamlined, then it's all about having workstations which are equally spaced and streamline the flow, which is very, very important. And if we want to have a streamlined flow and there are workstations, it's all about balancing them. So I think in a way, if you look at these systems are typically called continuous flow, simply because of this, that there is volume but little variety, therefore it's all about the flow happening, and typically it's all about splitting the work into several parts, and therefore these are some of the features that we will see in any continuous flow system. These are the features that we will always see in a continuous flow system. Therefore, the question in front of us is, what is important? What is significantly important in such systems? So that is where we need to be a little bit aware of. focus more attention on a few things. For instance, in a continuous flow, it's all about flow. Everything is about flow. As long as flow is maintained, the revenue is maximized, the profitability is all there. Therefore, how do we address the issue of flow? Which immediately brings us to the next question. It's all about work balancing. The whole design of the system critically depends on how do we identify how many stages, how is the capacity balanced, because if the capacity is not balanced, it's all uneven. So capacity balancing. And if one of the station breaks, the whole thing will come to a grinding halt because of the continuous flow nature. Therefore, how do you do the planning? How do you do the maintenance of such systems? These are very, very important. And lastly, I think slightest error in quality somewhere will halt the whole system. So the perspectives of quality, the criticality of quality not creating a certain kind of a disruption in the system. I think these are some of the issues that we need to worry in such continuous flow systems. Therefore, when we address capacity or when we address quality, we need to keep this in mind. Another interesting thing that we might find is typically in a continuous flow, it could be either a discrete industry like automobile. What I mean by discrete is the processes, or even this restaurant is a discrete industry. Processes are all in discrete stages, which means there could be inventory in between and so on. But the entire process industry, petrochemicals, pharma, these are all continuous flow, but they are called process industries. And interestingly, what we find is there is very little inventory there. The work in progress inventory is a function of your technology, because once it starts, it goes on and then it stops. Therefore, I think we need to understand such differences in inventory and inventory choices also. I think these are some of the issues we must be aware of when we talk of operations management in a continuous flow systems as what we have seen here.